Welcome to the debate. When you look at an industrial schematic, you see lines, symbols, text, but if you look closer, you actually see a philosophy. Today, we are opening the hood on the engine of industrial automation documentation, AutoCAD Electrical. Specifically, we're looking at the philosophy behind circuit design.
All right, let's move on to section 4, the art of wiring. We have built the skeleton, we have our ladder or a grid. Now we actually need to run the nerves. We need to draw the wires. Now, drawing a single wire in standard AutoCAD is incredibly easy. Click, drag, click, done.
Right. But we are talking about industrial power here.
Which means we are usually talking about three-phase power, 3 thick wires running in parallel.
And drawing 3 parallel lines manually is just tedious.
I mean, think about the workflow. You have to draw one line, then you have to use the offset command, type in the distance, click the line, click the direction, then do it again for the third wire, and then you have to trim all the ends so they line up perfectly.
It's slow, and honestly, it's highly prone to error. If your offset distance is even slightly off on one segment, the whole drawing looks sloppy when you zoom out.
Enter the multi-bus tool.
This is the ultimate productivity hack for power distribution design.
How does it work?
You select the tool from the ribbon, a dialog pops up, you tell it, I want 3 wires. Or 2 or 4, whatever you need. You set the spacing directly in the tool, say exactly 0.75 inches, and then you just draw.
Just click and drag.
As you move your mouse across the screen, the software automatically generates all 3 lines, simultaneously, perfectly spaced, following your cursor.
It sounds like drawing with a giant ribbon cable.
It is exactly like that.
Yeah.
And the orientation flexibility is where it gets really impressive. You can start drawing horizontally, and then just turn your mouse 90 degrees to go down vertically, and the software automatically miters and corners all 3 wires perfectly.
But wait, think about the physics of a ribbon cable. I'm visualizing a flat ribbon lying on a desk. If I try to turn it a sharp 90-degree corner while keeping it flat, it has to fold over itself. The wire on the inside of the turn has a much shorter distance to travel than the wire on the outside.
You are absolutely right, and that exact geometry problem exists on the digital screen too. Sometimes, depending entirely on exactly how you move your mouse through the turn, the software gets confused and might twist the wires.
Twist them.
Yeah. The top wire suddenly crosses over and becomes the inside vertical wire. The phases cross over each other. It looks like a tangled mess on the print.
So how do you fix it? Do you have to hit undo, delete the corner, and try to redraw it slower?
No. And this is where the source gives us a brilliant trick. This is a detail that really separates the novices from the seasoned pros.
The F key.
The F key trick. While you were actively in the multi-bus command mid-draw, you haven't clicked to finish the wire yet. And you see the wires hovering there looking twisted. You simply press the F key on your keyboard.
Just tap F.
Just tap it, or sometimes FT, depending on your specific version and settings. It stands for flip.
And what does it actually do?
It flips the internal wire routing sequence. It instantly untwists the ribbon right on your screen so the wires lay flat, parallel, and perfectly aligned around the corner. It respects the physics of the phases.
That is a massive time saver. Instead of fighting the mouse and deleting lines, you just tap a key.
Precision routing at the tap of a single key. However, there is a major danger zone with this multi-bus tool that we need to warn listeners about.
Yes. The source calls it the connection danger, specifically the starting point rule. Honestly, this part felt a bit like a logic puzzle when I first read it.
Really is all about conveying your precise intent to the software. Let's create a specific scenario so you can visualize it. You have an existing vertical 3-phase bus on your drawing. 3 wires running straight down the left side of the page, phase A, B, and C. You want to tap into that bus, create a key connection, and run a new branch circuit out to the right.
Okay, that's a super common task. So I grab the multi-bus tool, I set it to 3 wires, and I obviously need to click on the existing vertical bus to anchor the connection.
Right. Now, pay close attention. You have 3 existing vertical wires, a left, a middle, and a right. Or, if it's horizontal, a top, middle, and bottom. Let's assume horizontal for the example. Top, middle, bottom.
Okay.
If you click your mouse on the top wire first, and then drag your cursor down to draw the new branch.
The software tries to guess what you mean.
Exactly. The software thinks, the human clicked the top wire first. Therefore, I will connect the new top wire to the existing top wire. I will connect the new middle wire to the existing middle, and the new bottom to the existing bottom.
It maps them one-to-one in sequential order.
Yes. It's a perfect, clean connection. All phases match.
Well, what if I'm just clicking fast? What if I'm careless and I click the bottom wire first but still drag in the same direction?
If you anchor on the bottom wire, the software's logic completely shifts. It assumes the bottom wire is your primary anchor point. And depending on the exact angle of your drag, it might try to connect all 3 of your brand new wires directly to that single bottom wire.
Whoa, wait. If it connects all 3 new wires to one single existing wire, you've just created a massive dead short.
You've physically connected phase A, phase B, and phase C together into a single node.
A digital disaster, that's what Suntech called it.
And the really scary part is, on a super busy schematic drawing with lines everywhere, it just looks like a slightly larger green connection dot. You might not even realize visually that you've shorted the entire main power bus together.
Until the physical panel is actually built, someone flips the main breaker and things start literally exploding on the factory floor.
Exactly. The software will let you draw a bomb if you tell it to.
So the massive takeaway here is top-down logic. Always, always click in the sequential order of the phases. Guide the software. Don't make it guess your intent.
That is terrifying, but incredibly useful. All right, let's transition to section 5, intelligence over geometry. This is where we really get into the database aspect of the software that we touched on in the intro. Let's go much deeper, because in AutoCAD Electrical, a line is never just a line, it is a wire. And this is the core distinction you have to master. In standard vanilla AutoCAD, lines usually live on a default layer called layer 0.
Right.
They're just basic geometric vectors. If you draw a random line on layer 0 while you're in AutoCAD Electrical, the software completely ignores it. It assumes it's a drawing of a mechanical wall or a page border or just a random text note line. It does not see it as an electrical conductor.
So let's say a client sends me an old drawing that they made in standard CAD 5 years ago, and it's full of lines that look like a circuit. I can't just open that file in Electrical and start running wire reports and bill of materials on it.
No, absolutely not.
Yeah.
The software sees a blank page electrically. You have to promote those dumb lines. You have to explicitly tell the software, hey, this isn't just a geometric line, this is an intelligent wire.
How exactly do we do that promotion process?
You use a specific tool called Create or Edit Wire Type. This dialog allows you to take standard AutoCAD layers and assign them as official wire layers in the database.
So I could create a layer, name it something like RAD14AWG for 14 gauge wire, and define it electrically.
Yes. And once that layer is defined, you simply select all those dumb lines on layer 0 and move them onto your new RAD14AWG layer.
And instantly, once they hit that layer, they gain intelligence.
They gain a whole suite of properties. The database now tracks them. They have a defined color, a physical wire gauge, a specific material type, and most importantly, they can now be automatically numbered by the system.
The source material specifically mentions wire numbering as a sort of verification tool.
It's the ultimate litmus test. If you are ever staring at a complex drawing and you aren't sure if a specific line is actually a smart wire or just dumb geometry someone drew by mistake, you just run the global wire numbering command.
Now what happens?
The software rapidly scans the entire drawing looking for valid wires on valid wire layers.
Oh.
If your questionable line suddenly gets a number tag placed on it, like 101 or 24 VDC, congratulations. The database recognizes it as a wire.
But if it stays blank?
If it stays completely blank while everything else gets numbered, it's still just dumb geometry hiding on layer 0 or some other non-wire layer.
That is a great troubleshooting tip. And once it's officially a wire, we can fully control how it visually represents itself using standard properties, right? We can make it a continuous line, a dashed line, or a hidden line.
Exactly. And those styles have distinct meanings in the industry. A thick, continuous line is standard internal panel wiring. A dashed line usually implies a field wire, something that runs out of the control panel and across the factory floor to a sensor. And a hidden line might be used to show a mechanical interlock between two switches.
There was a really interesting note about line weight visibility that seemed like a classic UI trap.
Yes. You can go into properties and assign a really heavy line weight. Maybe you want the main power bus to be thick and bold so it visually stands out from the control wires.
Makes sense.
But if the global line weight visibility toggle, which is a tiny little button down at the bottom of your AutoCAD screen, if that is turned off, the screen will still just show a thin default line.
So you might spend 20 minutes reapplying the line weight property thinking it's broken or you're doing it wrong.
When really you just have the display toggle turned off. It's a classic trap. Always check the toggle.
Now, I want to bring up my absolute favorite term from the entire source material, the blue flashlight.
Oh, yes.
It sounds like a specialized detective tool.
In a way, it acts exactly like one. It's a really unique context menu feature. When you are doing intense wiring work, you really don't want to constantly move your mouse all the way up to the massive ribbon menu at the top of the screen to find your tools.
It breaks your focus.
Right. So if you just hover your cursor directly over any valid wire and simply right-click your mouse, you get this special radial marking menu that pops up right at your cursor.
And where does the flashlight come in?
As you move your mouse in a circle around this pop-up menu to highlight the different options, a literal glowing blue spotlight icon appears and shines directly on the tool you are about to select. It's a really clear visual cue.
But functionally, why is this radial menu better than just a normal drop-down menu?
Because it completely filters out the noise. Standard AutoCAD has thousands of commands. The blue flashlight menu is context sensitive. It only shows you tools that are specifically relevant to modifying wires.
Oh, that's smart.
It only shows you things like trim wire, copy wire number, or my absolute personal favorite tool in the entire software, Scoot.
Scoot. I absolutely love that name. It sounds so completely untechnical. Just scoot it over a bit.
It might have a funny name, but it is undoubtedly the most useful command in your arsenal. Let me paint a picture. Imagine you have a long horizontal wire, and right in the middle of it, you've placed a relay coil component. They are connected. Everything is great. But then you realize you need to move that relay exactly 3 inches to the right to make room for a new switch.
Okay, if I was in standard CAD, I would just select the relay and use the standard move command.
And if you did that in electrical, the relay graphic would happily move 3 inches to the right, but the wire it was connected to would just stay exactly where it was. You'd end up with a massive gap in your wire and a relay just floating in blank space. You've completely broken the electrical circuit in the database.
Disaster.
But if you use the scoot command instead of move, the software fundamentally understands the electrical relationship. You grab the component, you slide it 3 inches over, and the software automatically, dynamically stretches the wire behind it and shortens the wire in front of it to keep the electrical connection perfectly intact.
It creates the physical space you need without ever breaking the underlying logic.
Exactly. It completely respects the connectivity. And honestly, that right there is the fundamental difference between drawing pixels and modeling an intelligent system.
We are cruising right along into the final major technical section, Section 6, components and the template trap.
Components. If wires are the nerves, components are the vital organs of our machine analogy. The wires carry the signal, but the components actually do the physical work. They open the valves, they spin the motors.
Now, connecting wires to simple components like a light bulb is easy. But connecting wires to massive, complex components can be tedious if you have to do it one by one. But the source explicitly mentions a technique called window selection for these complex devices.
Yes. Think about a modern PLC module, a programmable logic controller. A single card might have 32 distinct input screw terminals on it.
And you definitely don't want to draw 32 individual lines manually.
No, thank you. That's a waste of time. So instead, you use the multi-bus tool we talked about earlier. But this time, you select component as your destination instead of just drawing into empty space.
Okay.
Then you literally just click and drag a giant selection window, a big green box, over all 32 connection points on that PLC block.
And the software just figures it out.
It's amazing to watch. It instantly calculates the optimal path for 32 parallel wires simultaneously. It routes them all using your designated wire layer, say drawing them all in red, and automatically snaps them perfectly to the 32 individual connection points. It literally turns a tedious 20-minute drafting task into a 5-second swipe of the mouse.
That is just pure efficiency. And the source also mentions something called interconnect components. What's that?
That's a slightly different tool. That's for when you need to specifically link two separate components directly to each other without manually routing the path, like connecting an auxiliary contact directly to a warning light.
How does that work?
You activate the command. You click component A. You click component B. And the software automatically calculates a valid path, draws the wire between them, and even routes it around any obstacles or other components that might be in the way.
It really is doing the drafting for you. Okay, now we have to arrive at the absolute climax of this deep dive, the trap to end all traps, the template trap. The source material treats this with a tremendous amount of gravity.
As it absolutely should, because this is the exact issue where multi-week projects literally go to die.
Let's lay out the scenario, because when I read it, it sounded totally baffling. You have a drawing. The rung spacing is set to 0.5. You look at it, it looks perfect. Easy to read. You open up a brand new second drawing. You also set the spacing to 0.5. But when you draw the ladder, the wires are practically sitting on top of each other. They are microscopic.
The question you have to ask yourself is, 0.5 what?
Units.
Units. It's always units. In the first drawing, the setting 0.5 meant exactly 0.5 inches. In the second drawing, it meant 0.5 millimeters.
And 0.5 millimeters is basically the thickness of a fingernail?
Exactly. It's completely invisible on a large D-size sheet of paper. The underlying problem is that the user carelessly mixed templates. They started drawing A using the Imperial Library template, usually designated as Library I, and then they started drawing B using the metric library template -library M.
But wait, if that happens, surely you can just use the scale command, right? Just grab a microscopic metric drawing and scale it up by 25.4 to match the inches.
Visually, yes. You can visually scale the graphical lines so they look bigger on the screen. But the underlying intelligence, the database, that completely breaks.
How so? Why does scaling break it?
Because AutoCAD Electrical relies on a highly precise internal coordinate database to track exactly where wires go when they jump from one page to another.
Okay.
So if a wire leaves page 1, which is imperial at the coordinate position of 10.0, and it tries to land on page 2, which is metric, the software gets hopelessly confused. Page 1 thinks the wire is at a position 10 inches down the page, but page 2 thinks that incoming wire is landing exactly 10 millimeters down the page.
Oh, wow. So the physical wires just don't line up at all. The source arrows and destination arrows will be pointing to completely different physical locations on the paper.
The connectivity utterly fails. The database is corrupted. You essentially have two completely separate, incompatible projects that cannot electrically talk to each other.
And what's the fix for that?
It is incredibly painful.
Yeah.
You basically have to scrap the bad drawing and rebuild it completely from scratch using the correct template. You cannot easily convert the underlying database units once the logic is fully built and compiled.
So the lesson here is totally non-negotiable, absolute consistency.
Always check your templates before you draw a single line, before you even save the file. You have to ask your team, are we an imperial shop for this project, or are we a metric shop? Pick exactly one and ensure every single .dwg file in the entire project folder uses that exact same standard.
It sounds so boring, checking document templates, but it is literally the foundation of the house. If the foundation is cracked with mixed units, the whole house falls down.
Or in this specific case, the machine you are designing never turns on because the wires don't actually connect.
We have covered a massive amount of technical ground today. We started with building the skeleton understanding ladders and spacing. We ran the NURS mastering wires, layers, and the multi-bus tool. We connected the organs using window selection for components. And we navigated the worst traps, avoiding the metric imperial split and the multi-bus short circuit.
It really is a comprehensive look at the entire electrical ecosystem.
If you had to distill all of this down, if you had to give the listener one single aha moment to take away from this entire SunTech breakdown, what would it be?
For me, it's the fundamental realization that AutoCAD Electrical is not a drawing tool. It is a database management system disguised as a drawing tool.
Database management disguised as drawing. That is a really powerful way to frame it.
It really is the only way to understand it. Every single click you make, whether
Yeah.
you're adding a rung, scooting a wire, flipping a bus sequence with the F key, you might think you're just moving green pixels around on a black screen, but you aren't.
You're writing code, basically.
You are actively editing a record in a massive interconnected SQL-style database. You are linking a grid coordinate to a wire layer and tying that to a specific manufacturer's component tag. The drawing you see on the screen is literally just a visual report generated by that data.
And that perfectly explains why things like retagging are so necessary when you switch from a ladder to an XY grid. You aren't just changing a piece of text on the screen, you are fundamentally updating the database index.
Precisely. And it also explains the silent failure of the grid labels. The database was working perfectly fine in the background, but the human visual interface was toggled off.
It brings me to a final, slightly provocative thought to end on. We have spent this whole time talking about how smart the software is.
Or
Right.
smart.
It auto-increments 50 pages of numbers to save us time. It magically flips wires around corners so they don't cross. It warns us about adding rungs where they physically don't fit. But the source material also highlighted how incredibly easy it is to accidentally dead short an entire factory floor just by lazily clicking the bottom wire instead of the top wire.
Yes, that is the paradox of the tool.
It makes you realize that the software handles the heavy lifting. It handles the tedious repetition, but the actual logic, the crucial engineering decision of exactly where the power flows and what it does, that relies entirely on the human operator's understanding of the system.
The software has incredibly strict rules, but it has absolutely no wisdom.
Which makes me wonder. We spend so much time learning to think in grids and ladders simply because that is how the software demands we organize the data. Are we actually designing the best possible circuits, or is the software's design forcing us to organize our human thoughts to perfectly fit its database structure?
That is the eternal question of automation, isn't it? We shape the tool to help us, and then inevitably the tool shapes how we think. The whole XY grid system is a perfect example of that. We are literally adapting our engineering language to make it easier for a database to index our work.
We are organizing our own minds to fit into the zone.
We really are. We become part of the machine.
Well, while you, the listener, wrestle with that philosophical nugget, and before you fire up the software to start your next massive ladder logic project, please, I beg you, check your templates first.
Metric or imperial. Pick one and stick to it.
That is the absolute golden rule. Thanks for
Thank you
diving
for
deep
watching
with
the
us
full
into the
video.
mechanics of
Don't
AutoCAD
forget to
Electrical.
subscribe to the
Go out
channel
there and
and
draw
ask
some
your
intelligent
queries in the
nervous
comments
systems.
below.
Happy engineering, everyone!
See you on the next deep dive.